Hello, eighth grade. Today we're going to continue solving equations, but now we're going to build larger equations that are going to involve multiple steps in order to isolate the variables. So these are called multiple step equations. So if you remember, we did talk about algebra tiles in the past, and we said that we could use these shapes to represent parts of equations. So just as a reminder, the rectangle, the green rectangle represents an x. The yellow square is a +1, a constant, and the red square is the opposite of that. It would be a negative. And so we can visually represent quantities using these algebra tiles. So for instance, say we had 2 rectangles and a yellow square, and then we said it was equal to 5 yellow squares. What do we mean? Well, we mean 2x's plus a 1 is equal to 5 because there are 5 squares. Okay, and so now what we can do with this is we can still go through the steps to isolate the variable, because our goal here is to know what the value of x is. And so how would we do that? Well, if you were dealing with tiles, physical tiles, you could eliminate a single yellow square on each side of the equation, and we still have balance, because when you take things away, as long as you do it to both sides, you still have balance. And so then we have 2 x's left, an x and an x, and we have 1, 2, 3, 4 constants on the other side of the equation. So now we know that for 2x's to equal 4, each x has to have a value of 2. So what did we do there? We took away the constant that was attached to the x's, and then we divided by the number of x's. So that's pretty much taking what we did with single step equations and just doing it in a particular order. So to solve a two-step equation, we're going to first undo any addition and subtraction that's going on, and then we will undo multiplication and division. So what does that mean? Let me show you. Say we have this equation, 3n minus 6 equals 15. So I said the first step that we need to do is undoing the multiplication or the addition and subtraction. And so what addition and subtraction is happening is this: we are subtracting 6, right? Because I've read the equation out loud to help me with that. 3n minus 6 equals 15. So we need to undo that. That means we need to get rid of that minus 6. And we do that by adding 6 to both sides of the equation. Okay, same thing. I'm going to draw that line. I'm going to see that negative 6 plus 6 is a 0 pair. So now we have 3 n's left on the left-hand side of the equation, and 15 minus 6 is 21. And now I'm going to undo the multiplication, because 3 n's means 3 times n, and we would do that by dividing each side by 3. And so now we have n is equal to 7. And again, I want to check my work by saying 3 times 7 is 21 minus 6 does give me 15. So our solution is correct. So let's try this one. 15x plus 3 equals 48. We want to undo addition and subtraction first. So that means we have to undo this plus 3 by subtracting 3. And if we're going to do it to one side of the equation, we must do it to the other side of the equation. So now we have 15x's is equal to 48 minus 3, which is 45. And now we have multiplication to undo. So we're going to divide both sides by 15. And now x is equal to 3. And again, I can go back to the original equation and check that by saying 15 times 3 is 45. Plus 3 more does give us 48. So we are correct in our solution. So let's try. I have 3 problems for you that I'd like you to try on your own, and then come back and see if you did it correctly. All right, so 9x plus 11 is equal to 2. We would subtract 11 from both sides of the equation so that we have a 0 pair here. We have 9x's left on the left-hand side. 2 minus 11 is -9. And then to isolate the x, if there are 9 of them, we need to divide both sides by 9. X is equal to -1. All right. We have 3t divided by 4 minus 10 equals -6. Now this 3t divided by 4 could also be thought of as 3/4 t. And if it makes it easier to think of it that way, you should do that. Give that one a try. Okay, same thing. We have to undo addition and subtraction first. We have this minus 10 here. So we undo that by adding 10 to both sides of the equation. So we have 3/4 t is equal to -6 plus 10, which is +4. And if we have a coefficient of 3/4 and that's being multiplied by t, the best way to get rid of that is to multiply by its reciprocal, which is 4/3. So we're going to multiply both sides by 4/3. So these cancel out and we're left with a single t is equal to 4 times 4/3, which is 16/3. All right, here's the third problem. 2b divided by 3 plus 13 equals 11. Again, that 2b divided by 3 could be thought of as 2/3 times b. 2/3 is the coefficient then. Give that one a try and then come back. All right, so undo the addition and subtraction first. We're adding 13, so we're going to subtract 13 from both sides. 2/3 b is equal to 11 minus 13, which is -2. And now we have to isolate the variable, right? Isolate b. To get to a single b, we're going to multiply by its reciprocal of 3/2. So now we have a single b that's equal to, and then I can simplify the 2's here. So we get -3. And if we wanted to plug it in to make sure it works, 2 times -3 is -6, divided by 3 is -2, plus 13 would give us 11. That does work. Okay, one last example I want to show you. And this is a multiple step equation. 5 minus x is equal to 17. So this 5 is a +5, right? So you could think of that as a sum or a addition part of the equation that needs to be undone with subtraction. So we could subtract 5 from both sides of this equation. And so that is a 0 pair, but we're left with a -x at this point, right? Because that negative sign goes with the x. And now we have 17 minus 5 is 12. Now, this doesn't give us a solution. It gives us the opposite of the solution, right? It's a -x. And so the coefficient of this x is -1. So we could divide both sides by -1 because it's like the coefficient is -1. And to undo that multiplication, we would divide. So now we have x is equal to -12. And if you check it, you can see that 5 minus -12 does give you +17. Okay, your assignment for today is to take a picture of the notes you just took and send it to me on Google Classroom. All right, thank you.